we'll be back into this section. As earlier on, we have been looking at measurements of dispersion, where we looked at measuring of interquartile range, measuring of percentile and decile. So now we are going to look at example how we can measure what we have been saying in the previous clip. So if you did not capture it, please refer back to that clip and then you master some methods which we are going to use. So first and foremost, the most important thing we covered was that if you have percentile or interquartile range, all of them they deal with the cumulative frequency. The value you obtain or you read, you get them from cumulative frequency. So that one will also be crucial in our frequency table. So now we have this question that the table below shows the marks obtained by 20 students in a mathematics test. There are 20 students. Marks obtained was ranging from 10 up to 20. And then number of students were distributed respectively according to their marks they obtained. Then they found out that one was for 10, about 2 up to 11 up to 14, all of them had the 2. But that one, we can show them in our frequency distribution table, because we said if you have any value and you have frequency, then to be more organized and to make it simpler for you to follow it, you should use the frequency distribution table, which you said the first value must always be the variable. Now in this case the variable is marks, which we are calling x. We shall say that the variable be x, or you can also put marks. We can say that the marks be x, or you can put exactly marks. Maybe to eliminate confusion, let us say, now for this case, let us use marks. But it is also okay if you use x. So marks, our first marks is 10. This one may not reach here. Let us put it up here. Marks. Then our first marks is 10. Then our second mark is 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. So this is our first column for marks. Then we said immediately after the first column of XOR, the one you choose to use, you take what we call the column of frequency F. Now in this case, our frequency is standing for number of students that have passed that exam or that test. The marks obtained by those students are what we are calling the variable, and which you can relate to be x. And then the number of students passing that particular number or with that particular marks is what we are calling the frequency. And then the frequency is distributed all over the marks. So we can say our frequency is 1 for those one with 10, and then 2 for those one with 11, again 2, 2, 2 up to those one with 14. Then we have 4, we have 2, we have 1, we have 2, we have 1 and 1. And then you remember what we say, that so long as you finish the column for frequency, make sure you sum that frequency and then it you get done with it. So another condition we said that after summing the frequency, when you have given the number of students or number of people you are dealing with, and then you sum your frequency, it doesn't be the same as that one, then that one doesn't qualify. So imply that you would have made some mistake. Let us see if for us we are qualifying to proceed. If you don't qualify to proceed, we shall check the mistake. So we add carefully. 1 plus 2, we shall get 3. 3 plus 2, 5 plus 2, 7 plus 2, 9 plus 2, 13 plus 2, 15 plus 2, 16 plus 1, 16 plus 2, 18 plus 1, 19 plus 1, 20. So implying we are correct, and the summation of f equals to 20. So since this number is equal to the other number, and then we have copied the frequency correctly, but also you can check if you have not interchanged. Because you may copy the frequency correctly, but when you have interchanged, maybe the one going for 15 and then end up on 19. Also that one will bring to wrong answer afterwards. So we said these values which we are determining the values that are reading from its cumulative frequency. Then it will become crucial for us to include the column for cumulative frequency. I think you still remember what we said about cumulative frequency. There were at least 2 conditions we set as our class, that the first cumulative frequency is always equal to the first frequency of that distribution. And then the second cumulative frequency will always be equal to the first cumulative frequency plus the next cumulative frequency to get the second. Or you get the first plus the second, you get the second cumulative frequency. And then this one shall start by saying that our first cumulative frequency is always the first frequency. And then the second one keep on adding. So we shall have 1 plus 2, we shall get 3 plus 2, get 5 plus 2, 7 plus 2, 9 plus 2, 13 plus 2, 15 plus 1, 16 plus 2, 18 plus 1, 19 plus 1, 20. Then this one drives us to the second condition which we need to meet, and which we say that the last cumulative frequency always must be equal to the last must be equal to the total number of students, or must be equal to the summation of frequency, or the summation of f. Then this one will bring us straight to the this one we shall get it straight to the question now. The first part, they are saying we find the 60th percentile. 60th percentile. But we say that the 60th percentile is denoted by P60. And then P60 can be determined by 60 out of 100 times NC value of cumulative frequency, or NC value from cumulative frequency. So our 60th percentile, this one will become 60 out of 100 times, what is n? N we said the total number of variable. What is the total number of variable? The total number of variable is the frequency of those learners. Otherwise, they are meaning the total number of students who sat for that paper. So our total number was 20. So obviously our n will become 20. So we shall look for this value. Then we shall start dividing. This 0 will go with this one, and then this one will go with this one. Then we shall remain with 6 times 2, which is the 12th value of the cumulative frequency. And then we say that after obtaining this one, to get the value corresponding to the 12th value, you come on your cumulative frequency and check for the value where the cumulative frequency, or this value here, will go into the cumulative frequency and it has no remainder. If you get that value, then straight you will come and read that variable. Okay? So we start looking for that value on our frequency distribution table. Then we have, if you put 12 in 1, can 12 go in 1 without a remainder? Obviously that one is not true. So it is advisable that to start looking for this value, at least start with the value which is of that type and above, or of the same size and above. So here, the value which is almost equal to 12 is 9, but 9 cannot go, 12 cannot go into 9, 12 minus remainder. And then, when you put 12 in 13, yes, 12 will go in 13 and can be accommodated without any remainder. So implying that our value of the 68th percentile is lying within this 13 cumulative frequency of 13. Then therefore we come and read this variable which is the max. So implying that the 60th percentile will be on those people, or the max of 15. So the P60, which is the 68th percentile, equals to 15, but those are max. The 68th percentile is 15. Then that one we shall go to the second question. You can capture this one. The second question is saying we calculate the interquartile range. So the interquartile range, we said we get interquartile range from the formula. Interquartile range, we said we get it from interquartile range. Say we get it from Q3 minus Q1 in our previous lesson. So Q3 minus Q1, but we look at how we can determine Q1 and how we can determine Q3. So we say that our Q3 is given by 3 out of 4 of NC value. So this value is 3 out of 4 times 20 C value. Then what is this value? It will come by 4, 1, by 4, 5. This one become the 15C value. That one coincides to our upper quartile range. So the 15C value, you come on your cumulative frequency and then read the value where it will go in 15. So, and it has no remainder. So the 15C value become our 15, so we shall use this one because it can go in 15 and it has no remainder. It will obviously mean that the upper quartile, it will lie in the range of the max, those one who got the max 16 max. Then when we check for Q1, we shall still follow the same procedure, which is 1 out of 4 times now the n is 20 value. Then this one become the 50 value. So after you come and read the cumulative frequency corresponding to the 50 value, it will just be that one, which is 12. So these are 12 marks corresponding to our lower quartile range. So we say that our interquartile range equals to upper quartile range, which is Q3 minus lower quartile range, which is Q1. Then, but we have now the value of Q3 minus Q1. So the value becomes 16 minus 12, which is 4. But these are what? Are marks. The interquartile range is 4 marks. So, in doing that one, we would have tackled the question. So, thank you for attending.